Hey geometry students, we are about to finish up with our trig part of chapter 9. So today we're getting into word problems, and these are some of my favorites. And we're going to talk about angles of elevation and angles of depression. So if you think about those words, elevate means to go up, to rise, depression, you get lower. So that's exactly what's happening with an angle of elevation and an angle of depression. For both of these, and it's important to remember this, they both start from a horizontal line, and an angle of elevation is going to go up from your horizontal line, and angle of depression is going to go down from your horizontal line. So if you look at the picture that I gave you, this dotted line right here at the bottom represents the line of sight for the person sitting in the wheelchair. So again, we're starting with a horizontal line, and from there, this angle is going up. That would represent an angle of depression. The guy that is standing, he also has a line of sight, which is that dotted horizontal line, and that angle is going down, and so that one is an angle of depression. But again, notice they both have to start from a horizontal line, and that is really important when we draw our pictures, that we have to have a horizontal line to start from before we can elevate, go up, or go down with an angle of depression. So let's start with example number 1. It says from the top of a tower, the angle of depression to a stake on the ground is 72 degrees. The top of the tower is 80 feet above the ground. How far is the stake from the foot of the tower? Okay, well, let me get my tower going. Now, you guys know I'm not the best artist. So this is what I'm going to use to represent my tower. I don't even know if it looks like a tower, but that's what I've got. Okay, so it says from the top of the tower, the angle of depression to a stake on the ground is 72 degrees. Well, remember we said we had to always start with a horizontal line. So up here at the top of the tower, I am going to draw a dotted horizontal line. And from that is where I'm going to have an angle of depression that's 72 degrees. And I'm going to use a straight edge because I like to have my pictures looking okay. I'm not really worried about if the angle measure is exact. I just want to at least make my picture look decent. So from that dotted horizontal line that I drew, going down is a 72 degree angle of depression. I'm gonna make that tower a little bit longer. I don't know what that is, y'all. I'm sorry. My drawing is really bad. So it says the top of the tower is 80 feet above the ground, otherwise known as the height of the tower. So in other words, from the top of the tower to the bottom of the tower is 80 feet. Can we see that? Okay. And it says, how far is the stake that's in the ground from the foot of the tower? Well, the stake in the ground is over here. I'll just write stake. And we want to know how far away the stake in the ground is from the foot of the tower. And so I'm going to call that side X because that's what we're trying to find. Now, ideally, this tower is going to be perpendicular to the ground. So that means that right here we have a 90-degree angle. Now you might be wondering, well, how does that 72-degree angle help us? Because if you notice, and I'm going to use a highlighter real quick, that 72-degree angle is not even inside of our triangle. And you're right. But if this tower makes a 90-degree angle with the ground, then it also makes a 90-degree angle with the dotted horizontal line that I drew. So if that right here, where my finger and my pencil are meeting, if that is a 90-degree angle, and I've already used 72 degrees out here, that means that this leftover amount right here is going to be 18 degrees because those have to add up to equal 90. Now, I know my picture is not drawn to scale. Clearly, my angle is bigger than 18 degrees. It's just a picture, though, to help us out. So that 72-degree angle that we had for our angle of depression we used it to help us find an angle measure that was inside of the triangle. That 72-degree angle was not inside of the triangle, but we used it to help us find one that was inside of the triangle. So if I'm looking at my 18-degree angle, X is opposite from it. The 80 feet is adjacent to it, so I have both of the legs. So that's going to give me tangent. So I'm going to have tangent of 18 degrees equals X over 80. And remember, we always want to get X by itself first. So I see division. So I'm going to do the opposite, which is multiplication. So I've multiplied both sides by 80. I need to use my calculator, make sure it's in degrees. I already did that. So I have 80 times tangent of 18 degrees. We're going to round to the nearest tenths place, and as you can see on mine, I got 25.9935757. So that's going to round it to 26.0. So our missing side is 26.0. I need some units, and we were dealing with feet. So the stake in the ground is approximately 26.0 feet away from the base or the bottom of the tower. All right, example number 2, it says a freeway entrance ramp has an elevation of 15 degrees. If the vertical lift is 22 feet, what is the distance up the ramp? Okay, so it says freeway ramp has an elevation of 15 degrees. All right, well, elevation means it's going to go up. Remember, we have to start with a horizontal line, and then we are able to go up, and we're going up 15 degrees. So hopefully that makes sense so far. We have a ramp, it's going up 15 degrees. It says the vertical lift is 22 feet. Well, think about a vertical line. Vertical lines go straight up and down. So I'm going to draw a line right here that's going to represent straight up and down. That means that I have this 90-degree angle right here, and that line that I just drew is the vertical lift. That's how high up the ramp is going. And the question says, what is the distance up the ramp? Well, that's going to represent the hypotenuse in this picture because that's the ramp. So we want to know how long, what the distance is of that ramp. So according to our 15-degree angle, the 22 is the opposite side. The X that we're looking for is the hypotenuse. So we're going to be using sine. So we're going to have sine of 15 degrees equals 22 over X. First thing we need to do is multiply each side by X. So now I have X times sine of 15 degrees equals 22. Then I need to get X by itself. So I'm going to divide each side by sine of 15 degrees. And now that I have X by itself, I'm going to use my calculator and do 22 divided by sine of 15 degrees. And so mine currently is in math print, and I don't want that answer because I want to round it to the nearest tenths place. So I'm going to go to mode, and I'm going to put it back on classic because I've highlighted classic. And I'm going to get out of that and type it again. So I'm going to do 22 divided by sine of 15 degrees. And I like this answer much better. So we're going to say that it is approximately 85.0. And I just need units. And they are feet. So our ramp has a distance of approximately 85 feet. All right, example number 3. A person at the top of a cliff, 100 feet tall, sees, so I left out an S there, that wouldn't make sense if it didn't have it, sees Gilligan's boat. His sighting of the boat is at an angle of depression of 10 degrees. How far is the boat from the base of the cliff? Okay, so let's suppose that my drawing is awesome. And there's my cliff. Or something like that. And we have this person. So it says the cliff is 100 feet tall. So right here we have that this is 100 feet high. and a person is sighting Gilligan's boat at an angle of depression of 10 degrees. Well, remember, with both angles of elevation and depression, we have to start from a horizontal line. So I'm drawing a horizontal line, and from that horizontal line, we're gonna have an angle of depression, so it is going to go down 10 degrees. All right, the question is, how far is the boat, because there's my boat, there's Gilligan, from the base, otherwise known as the bottom of the cliff. So what we want to find out is that measurement right there. So again, remember here I have this 90-degree angle. Again, we're assuming that the cliff is perpendicular to the ground or to the water there. And we need an angle measure besides that one, the 90-degree one. We need another angle measure inside of our triangle. So remember, again, right here, up here, the cliff and this horizontal line that I drew is going to form a 90-degree angle. We have 10 degrees outside of the triangle. That means that inside of the triangle, we're going to have 80, because those two together have to add up to 90 if it's perpendicular. So now looking at that 80-degree angle, x is opposite, 100 feet is adjacent, and that means that we're going to use tangent. So I have tangent of 80 degrees equals x over 100. I need to get x by itself, so I'm going to multiply both sides by 100. That works perfectly, so now I'm going to use my calculator and type in 100 times tangent of 80 degrees. And I'm going to find out that it is approximately 567.1 feet away. All right, hopefully these have been pretty easy so far. The biggest part is you just have to get your picture right. Once you've got your picture, the problems really aren't that difficult to set up. Okay, example 4 says that a surveyor is 130 feet from a tower. The tower is 86 feet high. The surveyor's instrument is 4.75 feet above the ground. Find the angle of elevation from the instrument. All right, so we have a surveyor, it's a person, and then we have this tower. My last tower was pretty terrible. I'm not gonna make this one try to look pretty. There's what I can draw for a tower. All right, here's what we know. The surveyor is 130 feet from the tower. Hold on, Coco, stop scratching that couch. Sorry, y'all. The tower is 86 feet high, so from top to bottom is 86 feet. All right, now the surveyor is using an instrument. So I'm just gonna draw this thing right here. That's representing whatever instrument that he's using. And that instrument is 4.75 feet above the ground. So in other words, from top to bottom, right there, is 4.75 feet. So he's using the instrument, and our goal is to find the angle of elevation, not from the ground, not from the person, the surveyor, but from the instrument. So in other words, first of all, let's get this dotted line going right here, because remember, we always have to start with a horizontal line. So I've got a horizontal line coming out of the instrument, and then angle of elevation means that I'm going to go up. So from that, I'm going to draw a line from the instrument to the top of the tower, and I'm going to call this X. That is going to represent the angle of elevation. That's what we're looking for at the end of this problem. Okay, so let's look at our picture. Over here, we should have a right angle. We're assuming that the tower is perpendicular to the ground. Now let's look at the 86 feet, because the 86 feet is not going to be what we use, because the 86 feet doesn't represent a side in our triangle. What the 86 feet represents is from the top of the tower to the ground. But here's what we know. We know that from here to here, this right here, is 4.75 feet. So if I take 86 feet and subtract away the 4.75 feet, that means that in my triangle, I have 81.25 feet. That's going to represent the opposite side of angle X. Now, what else do we know? Well, we know that the instrument, the surveyor, is 130 feet from the tower. Now, this line right here that represents the ground is going to be parallel to that dotted line that I drew from the instrument. And so these two, then that means that this is also right here 130 feet, and that is going to represent the adjacent side. So I have opposite and adjacent, which means we are going to use tangent. So we have tangent of angle X equals 81.25 over 130. Now this is kind of one of the newer problems that we did in the last lesson where we need to find an angle instead of a side. So remember, if we want to get rid of the tangent function, we are going to use the inverse tangent function, and whatever you do to one side, we also have to do to the other. So inverse tangent cancels out regular tangent, which means now we have X by itself. And now I need to plug into my calculator inverse tangent of 81.25 divided by 130. Again, we're gonna do to the nearest tenths place. So I'm getting approximately 32.0. Don't forget degrees, that's our unit of measure because we're finding an angle this time instead of a side. So our angle of elevation is approximately 32 degrees. Okay, let's look at example 5. It says the tallest fountain in the world is located at Fountain Hills, Arizona. If weather conditions are favorable, the water column can reach 625 feet. Let's talk real quick about water column. That just means how high the water is going to be as it's coming out of the ground. It says, suppose Kevin visits the fountain on a perfect day and his eyes are 5 feet from the ground. If he stands 40 feet from the fountain, find the angle of elevation for his line of sight to the top of the spray. Okay, so we have this water coming out of the ground. And it says that the water column, so that I just drew, can reach 625 feet. That is pretty tall for water to be going up. Okay, we have a guy named Kevin. I'll put him over here. And he is visiting the fountain on a perfect day, and his eyes are 5 feet from the ground. If he stands 40 feet from the fountain, we want to find the angle of elevation for his line of sight. So we're not finding the angle of elevation from his feet, we're finding the angle of elevation from his eyes. So right here is where I would say his eyes are going to be. So let me draw my dotted horizontal line, because remember, you have to have a horizontal line before you can draw an angle of elevation or depression. And from his eyes, we're going to draw an angle of elevation that goes up. And that's what we're trying to find, is what's the measurement of the angle of elevation for his line of sight. So a couple things we know. We are going to again assume that this water is going to form a 90-degree angle. This dotted line that I just drew is going to be the same distance as how far away he is from the water. So that represents 40 feet. One other thing they told us that I haven't put into the picture yet is that it says that his eyes are 5 feet from the ground. So in other words, this distance right here represents 5 feet, which is good to know because we are looking at this triangle that I am highlighting in yellow, and the 625 feet is not going to be the number that we're going to use because we have to subtract away this 5 foot distance right here, which means that the number we're going to use from here to here is 620 feet. And that 620 feet is opposite of angle X. The 40 feet is adjacent to angle X. So again, we're going to use tangent, so pretty easy to set this up. Tangent of angle X is equal to 625 over 40. Just like in the last problem, we need to get tangent to go away. So we're going to use the inverse tangent function on each side. That allows us to get X by itself. and then we're going to use a calculator. So inverse tangent of 625 over 40. We're going to keep doing to the nearest tenths place. And I am getting 86.3. Again, include degrees. That's our unit of measure because we are finding the angle. How are we doing? Hope we're doing okay. All right, this is one of my favorite examples. Kind of reminds me of the movie Hidden Figures. Hopefully everybody has seen that. If not, take this time while you're at home with all these hours of nothing to do. Rent the movie. Such a good movie. The book was excellent as well. Had a lot more details than the movie is, I will tell you that. But definitely check out the movie if you haven't. True story about African American women mathematicians who were instrumental in flights to space. All right, so on July 20th, 1969, Neil Armstrong became the first human to walk on the moon. During this mission, the lunar lander, which was named Eagle, traveled aboard Apollo 2. Before sending Eagle to the surface of the moon, Apollo 2 orbited the moon 3 miles above the surface. At one point in the orbit, the onboard guidance system measured the angles of depression to the far and near edge of a large crater. The angles measured 18 degrees and 25 degrees respectively. Find the distance across the crater. A lot of words. The key to this problem is going to be the picture. If you can get the picture drawn accurately, this really is not a hard problem. So let's go back to the beginning and we're going to take it step by step. So we have the Eagle, and the Eagle is orbiting the moon 3 miles above the surface. Okay, so let's just say that this right here represents the surface of the moon, and then we have the Eagle. Okay, now don't make fun of my drawing too much because we all know that my drawings are pretty terrible, and this one should prove to be just as terrible as they normally are. And there's, okay, that's as good as I got, y'all, sorry. I am no Miss Philippontu, that is for sure. But here's what we know. The Eagle is orbiting the moon 3 miles above the surface. So from here to the surface of the moon is a distance of 3 miles. Okay, so it says at one point while it's in orbit, the onboard guidance system measured the angles of depression to the far and near edges of a large crater. Okay, so we know there are craters on the moon, so let me just draw a crater right here. Here's my crater, that big hole, if you will. And it says that it measured angles of depression. There are 2 of them, okay? Now let's talk, because remember we said angles of depression always have to start from a horizontal line. So the first thing I'm gonna do is draw my horizontal line. So this is just the route that the Eagle is taking. And from that route, we're gonna have 2 angles of depression. Now notice this word right here, respectively. So if I go back and I reread this sentence, angles of depression, the first one it says is the far edge. And the first number that it says is 18 degrees. So when it uses that word respectively, it means that because this was mentioned first and this number was mentioned first, those 2 go together. So from the Eagle to the far edge of the crater, we have an angle of depression of 18 degrees. So don't let that word respectively throw you off. It's just letting us know that the thing that was mentioned first gets the first numerical value. So then it talks about the near edge of the crater, and the second number it mentions is 25 degrees. So those 2 things go together. So I'm gonna draw another line, and I'm gonna go to the closer edge of the crater. Again, it started from that horizontal line that I drew to that other line that I just drew, and that measurement is a total of 25 degrees. So hopefully this picture is making sense. Y'all send me some emails if it's not. The question is, find the distance across the crater. In other words, this piece right here, we want to know how wide is the crater. I'm going to call it D for distance. So if you're looking at this picture, and watch my pencils outlining this triangle. See it? There's a problem. And the problem is that that is not a right triangle. And I can't use SOHCAHTOA. I can't use sine, cosine, or tangent right now without having a right triangle. So I have a little bit of work to do. Here's what I see. I have a triangle right there. That is a right triangle. And then I have a triangle right here. That's also a right triangle. Do you see it? You see a smaller triangle on the right, and it's enveloping, the blue one is enveloping that smaller triangle, the yellow one on the right. Okay, so let's talk about some numbers. Let's talk about the yellow one first, which I'm just gonna redraw right below it. Here's what I know about the yellow triangle. I know that I have a 90-degree angle right there. I know that from here to here represents that 3 miles. So that represented how high the eagle was from the surface of the moon. And then let's go back to the big picture right here. From that horizontal dotted line that I drew down to this yellow line right here was a measure of 25 degrees. Now remember that that needs to form a right angle right here. Does everybody see that? So if I've already used up 25 degrees right here, how many degrees would be left? And that would be 65. So I have a 65-degree angle right there. All right, before I continue, let's talk about the blue triangle, which I'm just redrawing. All right, the blue triangle is a right triangle. This side is also 3 miles. Now let's talk about an angle measure for it. Let's look at this picture right here. Again, from the dotted line, that angle of elevation down to this side right here that's a part of the blue triangle is 18 degrees. Again, this needs to be perpendicular. So if I've already used up 18 degrees, how many degrees would be right here inside of that blue triangle? That would be 72, because 72 plus 18 is 90. Okay, so you might be wondering, how is that going to help us solve for D? Well, let's look at the big picture. If I want to find the distance across this crater, what I could do is find this whole side right here in blue. I'm going to call it X. And then I could find this side right here in yellow. I'm going to call it Y. And if I could find X and Y and subtract them, that would give me this leftover amount for the length of the crater. So X is a part of the blue triangle. It's the bottom of the blue triangle. Y is the bottom of the yellow triangle. So I would be able to do the X, because it's the longer side, minus Y, because it's the smaller side, and that's going to give me that leftover amount, which is going to be the distance across the crater. Hopefully that makes sense. And now we're just going to do a couple of easy problems, because we've already now done the hard part. So I'm going to start over here with the blue triangle, and 72 degrees, as I'm looking at that, X is opposite, 3 is adjacent. We're going to use tangent. So we've got tangent of 72 degrees is equal to X over 3. I see division. I'm going to do the opposite and multiply each side by 3. And then I'm going to use my calculator. So 3 times tangent of 72 degrees, I'm going to get approximately 9.2. All right, let's look at this yellow triangle. Y is opposite from our 65-degree angle. 3 is adjacent, just like it was in the other triangle. So again, we're going to use tangent. So tangent of 65 degrees is equal to Y over 3. Again, I see division, so I'm going to do the opposite of that, which is multiplication. And then I'm going to use my calculator. So 3 times tangent of 65 degrees. It would help if I could type it in correctly first. And so I'm getting that y is approximately 6.4. Now this is all great math work, but it doesn't answer the question. Remember, the real question is find the distance across the crater. And earlier we said if we could find the whole piece and subtract away this amount over here, then that will give us the distance across the crater. So we're gonna have 9.2 minus 6.4. Now you might be wondering why I'm still using the approximate symbol, and the reason for that is because I'm using values that have been rounded. So these are not exact values. So I'm going to continue to use that approximate symbol, and I'm going to find that the distance across the crater is 2.8 miles. That is a very, very wide crater. All right, so what I would like for you to do is try example 7 on your own. I'm going to stop the video, and then I will add another video that goes over example 7 so that you can check your work, okay?